everyone, I am from Marwadi University studying in semester 3 of Computer Engineering, and I am going to discuss the topic guided media from the chapter Transmission Media. Transmission media is a physical path between transmitter and a receiver. Basically, transmission media is divided into two parts, guided and unguided. Guided media has a wired path to transmit data. Waves are guided along solid medium. Guided media has three paths: twisted pair cable, coaxial cable, and optical fiber. Twisted pair. It consists of two conductors which has its own insulation and are twisted. One is used to carry signal and another is used for ground reference. The receiver uses the difference between them. Noise or crosstalk may affect both. Here, noise is unwanted sound and the crosstalk is any phenomenon by which a signal transmitted on one circuit or channel of a transmission system creates an undesired effect in another circuit or channel. Here, noise on parallel cables or lines is shown. Calculating their difference, we get 4 units of noise effect. Here, noise on twisted cables or lines is shown. Calculating their difference, we get 0 units of noise effect. So, we can conclude that by adding the twist, there is reduction in the noise effect. Generally, color-coded twisted pairs of insulated copper wires are encased in plastic sheath. Here, each wire has a diameter of 0.4 to 0.8 mm. If there are more twists per foot, there will be more resistance to crosstalk. It is of higher quality and more expensive. Number of twists per foot or meter is called twist ratio. More twists needed more cable, which may increase attenuation. Attenuation is reduction in strength of cable. Balance is needed between minimizing the crosstalk and reducing the attenuation. So, these were some of the characteristics of a twisted pair cable. Here, the 2 pairs and 4 pairs twisted cables are shown. In the modern networks, they use 4 pairs packed in together. Twisted pair is relatively inexpensive, flexible, easy to install, and easily accommodates different topologies. There are 2 types of twisted pair cables, STP and UTP. Shielded twisted pair, STP. It consists of twisted wire pairs that are not only individually insulated but also surrounded by a shielding made of metallic substance such as a foil. Sometimes braided copper shielding is also there. It acts as a barrier to external EM forces. Unshielded twisted pair. The twisted wire pairs are covered in a plastic sheath. There is no additional shielding. It is also less expensive and less resistant to noise. Coaxial cable. It has a conductor such as copper wire. Then above that it has an insulator. Then again a conductor above that insulator, and then again an insulator, and at last a plastic cover. These cables are on a single axis. They are used in TV cables such as RG59 as a thin Ethernet in the telephone cables as RG58 and RG11 is used as a thick Ethernet. Optical fiber looks like this. Optical fiber. In this, signals travels in the form of rays. It has one core, it has a cladding in its outer face, and above that there is a jacket. These all things you can see in the figure given. In the next slide, optical fiber works on total internal reflection. Optical fibers works on also different modes. Here the different modes are given. First is multimode, single mode. There are subtypes in multimode, that is step index and graded index. Multimode. It refers to varieties of angles that reflects and multiple propagation paths also exist. Here in a core, different types of angles are reflecting, many signals are propagating in different ways. This is called a multimode step index. Here at next we are having a multimode graded index. This is similar to multimode or a multimode step index, but it has more focused signal rays. As you can see in the figure. Now we are having single mode. In single mode, the core is thin, so only a single ray can pass through it. So when the core radius is reduced, there will be less reflection of angles. As you can see, the core radius is so small that only one signal can pass at a time. Optical fiber type. Its types are defined on core and cladding. If the type is 50 by 125, then 50 will be its core in micrometers and 125 will be its cladding in micrometers. We can take second type as 100 by 125. Here 100 will be its core and cladding will be 125. Here first and second both has mode multimode graded index. Now let us see the third type. If we take third type as 7 by 125 and it is of single mode where 7 is the radius of the core and also it is very less. So the core will be 7 and the cladding will be 125. If we compare all the three guided media, then this will be the result of the comparison. If it's twisted pair cable, the cost will be low and its bandwidth data type will be till 3 Hz. It has a very high attenuation. Attenuation is the reduction in the strength of cable, and security will also be very low in the twisted pair cable. Now, in coaxial cable, the cost will be moderate, bandwidth data rate is high, 350 MHz as compared to twisted pair, and security is also low. If we see in optical fiber, the cost is very high, bandwidth data structure is very high, 2 GHz. Now, if we want to transfer data very fast, then optical fiber can be used. And security is also high of the optical fiber. And finally, I end up here with the references from which I got a beneficial help for making my presentation. Thank you. This is a twisted pair cable. This is how it looks like. As I told you that modern devices uses 4 pairs of twisted pair cables. Here 4 pairs of twisted pair cables which are used in modern devices is shown. This is an coaxial cable. It has a conductor insulator and then a plastic sheath coated around it. Now, this is an optical fiber. Optical fibers are of different kinds and different sizes. Here, different sizes are shown. This is an optical fiber. This is the first size. This is the second one. And this is the third one. We can get each and every sizes in market easily.